This illustration deals with the temperature limitation of conductors in accordance with 310.14A3, which I call items 1 through 4. The purpose of the change is section 310.14A3 has been relocated from 310.15A3 in the 2017 National Electrical Code. Now you're going to find a lot of big changes in section numbers here as we go through this. Now first we're going to look at item number 1. Now notice that's the arrow pointing toward the conduit containing the conductors. Now we're routing through an ambient temperature of 100 degrees Fahrenheit. 310.15B1, table 310.15B1, and that table's been renumbered, and 310.15A3 informational note, item number 1. Now all those tables and sections have been renumbered. Keep that in mind. Now, number 2, we go up at the top of the illustration on the right, and you see it says calculated load. Now, the connected load is 14.4 amps. The calculated load is 18 amps, and you get that in the calculated load boxed in information. 310.14A3 informational note 1, item number 2, or informational note 2, and 210.19A1A, we take 125% of 14.4, and from connected load, we determine based upon the load being used for 3 hours or more, we pick up 18 amp. Now that's item number 2. And that's what the engineer looks at, or the electrician that has the responsibility to calculate this load based upon where they're going to route these conductors. And you should route it so you don't let these conductors get overheated based upon how you route them. Now, looking at number 3, look at item number 3 right below the equipment there, which says a rating of a connected load of 14.4 amps. Item 3. Now, 310.14A3 and informational note 1, we look at item 3, and 110.14C1 little a, and we're saying, well, all these terminals are 75 degrees C as talked about in 310.14A3 informational note 2. So we're saying the terminals are 75 degrees C at the equipment, also at the panel board. So that's determined. And then when you go to the item number 4, we have 8 current carrying conductors in the raceway in accordance with the new table 310.15C, which used to be table 310.15B3A. You see how all this has been renumbered? And then the golden rule that used to be 310.15A3 is now 310.14A3. It's informational note 1, item number 4. And we know we haven't exceeded 9 current carrying conductors, so if we have 8, it's 70%. Now, correction factors would be based upon this 100 degrees Fahrenheit in item number 1 that we looked at. Now let's look at the table and make application of this new relocated, renumbered section, and these rules have not changed, really just section numbers. Now, notice table 310.16 and step 1. Well, that used to be table 310.15B3A. They changed all that and then went back, changed it back to how it's been in the code for years. You know, just creating a hell of a problem, really, but to some of the facilities and what have you. But that's okay. I like table 310.16. And then you select your conductor, number 12 conductor, THHN is 30 amp. If this is in conduit, then I can go to 110.14C1A. It's 100 amps or less with 30 amps. So we know these terminals would be 60 degrees C if they're not marked 60/75. and then the equipment is 75, so we're in business. Now, in other words, at 75 degrees C terminals is listed in item 3. Now, note 2, we go to table 310.15C1 is in car. We have 8 conductors that requires a 70% D rate from this table that used to be 310.15B3A. And notice 70% is selected. We haven't put more than 9, so we're not in that 50% D rate. So applying correction factors now, that's based upon the 100 amps here in item 1 that you see that we just looked at. And if we go to our table 310.15B1, B as in boy, that used to be table 310.15B2A. The 100 degrees Fahrenheit, no change. There's not any change. It's 91%. So item 2 for the 8 current carrying conductors, 70%. Note 3 for correction factors, 91%. Now let's do the math in step 4. We do our math in step 4, and you see your sections are listed there from 2 and 3. We take 70% of 30 amps, take 91% of that, we come up with 19 amps. Now you look at that and say, all right, now I've got to compare and see if that will supply the connected load. Well, 14 amps, it supplies it. The calculated load, 18 amps, 19 amps, supplies that. So we're okay there. Now we got to select an overcurrent device. What's the next size overcurrent device above the calculated load, 18 amps? 20 amps. So we go to table 310.16 and look at 240.4D as in dog, and look at really our table 240.6A, and we notice a number 12 conductor with 19 amps requires a 20 amp device. So the 20 amp device protects the 60 degree 12 AWG conductor wiring that's good really for 25 amps, but it protects it at 20. And then the 20 amp overcurrent device matches up to the calculated load, moving up to the next size, which 240.4B as in boy allows. Now, so the sections that you review for this overcurrent device in would be table 310.16, 240.4D that deals with small conductors, number 10 down to number 18. And then table 240.6A, which would deal with selecting your overcurrent device, which is 20 amps above 19, which 240.4B allows. Now, checking those sections, then you see that this illustration completely complies with the new code with its relocated and renumbered sections.